Okay, I think I can start. Okay, hello everyone. Okay, welcome to can start. Okay, we start again. Hi everyone, welcome to our second webinar. And today we will do the projects walkthrough for data modeling in both Postgre and Apache Cassandra. And as we all know, one is relational data modeling and the other is NoSQL data modeling. And I will be going through the projects with you today, and so you can see my process. And on the other hand, actually, lots of you have completed these two projects, and currently you're working on data warehouse. So in the end of this webinar, I would like to share several questions with you, and hopefully you would find them useful. Okay, so now let's start with our webinar. So first I would like to share the screen with you. Screen share. Okay, perfect. Share. Okay. Let me check if you can see my screen or not. Okay, good. Okay, cool. It's here. So this is our second webinar, and the main thing we would like to talk is project working through data modeling with Postgre and Apache Cassandra. And so here's the outline. First, we would like to do the project walkthrough, and then we will give some quiz and questions for those working on data warehouse right now. Okay, and yeah, the goal of these two projects is to create a database and ETL pipeline in both Postgre and Apache Cassandra, so that the company Sparkify is able to do some analysis on extracting user behaviors, such as how often a user listens to music and which artist is the user's favorite. Okay, so let's go through the first project, data modeling with Postgre. And here we have to-do list. So first is design a star schema using the dataset Udacity gave us. And second is we have to complete the 6 files in project workplace one by one. So now let's go check. Here is the project introduction. Basically, we're working for a startup Sparkify, and which is a music streaming app. We need to create a database for their analysis team. And the data they give us, basically it's in JSON format, as you can see. And so that's all we know. We have JSON, and we need to do relational data modeling for Sparkify's analysis team. So now let's check the data side. So we have two data sides. One is sound data side, and it's JSON format. And these files are of this form, of the following form. So now we can see one example. So here we have number of songs, artist ID, artist latitude, artist longitude, this is location, a lot of artist name, song ID, title, duration, year. Basically, those are the information of songs and artists. Another one is log data. So log data, it's also log data site. It's also in JSON format. And here is an example of one of the JSON file. You can see we have artist information and author's first name, gender. These are the, I guess this is the user information. Determine session, last name, length, level, location, method, page, registration, session, song, status, TS, this is kind of time, and user agent, user ID. Okay, and here it's the here it's we can read JSON into panda frame by this function read JSON. Okay, so if you want to know more about the JSON file, here we have Udacity course which talking about the JSON file. Okay, now it's the project instruction. So in the to-do list, I mentioned we need to do two things. First, to build schema for song play analysis. And in the schema, and in this instruction already tell us what the schema looks like. So we have one fact table, song play, and which has columns like song ID, start time, user ID, level, song ID, artist ID, or song play ID, the first one, and song session, location, user agent, and four-dimensional table users, which will be used to store users' information like user ID, first name, last name, gender, and level. Second one is songs information, song ID, title, artist, year, and duration, and artist ID, artist table, and is used to store artist information. And the final is time. Okay, start time. As we can see here, actually, it's dimensional modeling, right? Because we have fact table and dimension tables. Okay, so, and we also have project template. As you can see here, all we need to do, we need to follow the steps. Yeah, we need to complete the 6 files and following those steps. So first, we need to complete the SQL query Python py. Yeah, we write all the queries we need to create table and to drop table in SQL query py. And then we have another Python script called create tables. By this, we're gonna create our table. And after we create the table, we'll use test IPython to test and to see if we create a table successfully. And then we will build ETL process in ETL IPython. And this one IPyMB actually it's, yeah. Okay, so then after we finish this, we will run, we will complete this ETL Python script, and then we'll run and test it in this test file. And after we're done with all the files, that means we finish our like a main process, that is create tables and build ETL pipeline. And finally, we need our doc which is README, and to introduce the project we have done. Inside the README, we need to discuss the purpose of the database we just built, and we need to state and justify the database schema we designed and the ELT pipeline we designed. And the third is optional one. We can provide examples query. In the example queries and result to tell people, okay, what we have done, it's useful and it's helpful. And for README in general, we use Markdown file, and here is the get for Markdown. Okay. So after we done all these 6 files, we need to check, we need to read the project rubric to see if we meet all the specifications stated here. So it's a very important, and this one gonna decide if your project will pass or not. Okay. So okay. For this project, I'm gonna do it locally. So this is my Jupyter notebook, and here I have all the files I need. Here's the data, and this is the SQL query, and this create table, and here is the test, and this one is ETL and ETL Python. Okay, so let's continue. So here's the star schema. I draw a graph so that I can see it clearly. In the sampling, I have those many columns. I have user, song, artist, time. This one is fact table, and those 4 are the dimension tables. So generally speaking, it's dimensional modeling. Okay. So let's work on this SQL query Python. So we need to write create statement and drop statement in here. So here I'm gonna give you some examples for drop first. So because we need 5 tables, so here I have some play tables, user table, song table, artist table, and time table. Drop because I'm gonna drop them later. So the statement will be like drop table if it exists someplace, and you can complete the rest part here. And then for the create tables, so first I create some play table create, and also I have user table create, song table created, and create artist table create, and time table create. Okay, I think I'm gonna hide this one. Okay, so the statement inside is create table sample, first column, sample ID, and this one is primary key and serial, star ID, data type, and other condition, user ID, data type, other condition, which is not known, level, data type, song ID, data type, artist ID, data type, session ID and data type, location and data type, and user agent and data type. Okay. And then also you can complete the rest 4 tables by yourself, I guess. Okay, so yeah, and also we need to read the insert record, right? Because we need to insert information to the table we just created. So here's sample table, insert into sample. When we have those columns, so we insert start time, user ID, levels ID, artist session ID. Yeah, everything. Yeah, actually, because here we have like triple code, I think we could do this. Yeah, so that we can see everything, because here is like triple code, so triple double code, I guess. So we could have multiple lines inside the code. So we can do this. Okay, so this is insert. Okay. And yeah, and we know actually in this Python, the SQL query Python, we also have like a list. I'm gonna use it later. Okay, so yeah, now let's let's complete the create table Python. For this one, we need to, because we need to create a table, so first we need to create a database, right? So we import all the library. We're going to use Python driver, because that's what we learned from the classroom. Okay, so this is the library we're going to need, we will use. And right now, this Python script became a module, and we import the create table query and job table queries. These are the two lists in the SQL queries. Okay, so first we create database. Of course, we need to create database. Then we're gonna create table in this database. So to create database, first we need to connect it to a default database. Then we create a database, which we're gonna call Specify database. And then we connect it to, oh, I think here it's wrong, right? Oh yeah, close, sorry, it was okay. Yeah, then we close the connection to the default database. Then we connect to the Spotify database. And after this, so right now we have the go and connect to the new database we have. And here we will complete the job table and create table function. So the main function is we created a table, and then we drop the table and we create a table with all the data tables. Yeah. Okay, so this is the create table Python script. So let me run it here to show you how it works. Yeah, actually I should run it in the terminal, but I don't want to. I want to use the not this one. Test. Yes. I want to use the magic function. So use this one. Run create tables py. Okay. Ha. Yeah, I got an error. So other session uses this database. So I think I have to restart it. Restart. Okay. Yes. Okay. Let's run again. Okay, it's worked right now. So I already run the create table Python script. I suppose I already create all the tables. So let me check. So here I can connect to the SQL, and I connect to the Spotify database I just create. Now I want to see what's in my someplace table, and right now because I haven't insert anything yet, so I suppose dot 0, and it's the same for the user table, and for the sound table, for the artist table, for the time table. Okay, so now we can see we successfully create all the table we need. And good. So now we could work on ELT. Okay, for this ELT process, I just state this star schema here so that I can check what columns do I need in each table. Okay, so first I install all the library I need. Here again, the SQL query, it's module, so I can import it. Okay, so now connected to the database, Sparkify database DB, and because I'm doing it locally, so probably it's a little bit different. If you want a little bit different, if you work in Udacity's workplace, and here have get file function. I guess this one, if you give a file path, then it will return you a list. This list contains all the files like in this file path. Okay, so if you're not sure what this works, we can go here. So yeah, first we process some data. We have like two data sets. First is sound data set, another one is log data set. So first we process sound data, because from this sound data set we can get all the information about songs and artists, right? So okay, so first here is here's the file path, data, sound data. If you want to see, it's here, data and sound data, right? And yeah, then sound file equals get file, get files. It's the function we define here. Then we get the input is the file path. So we're gonna have a list, a sound file, which is a list. And we can check the length of the list. So I print the length of sound file, so I have 83 files in this list. And right now I want to check, okay, what each file looks like. So I can use Python library read JSON sound files 0 because it's list. So I take the first file, and then I can check the data frame. It looks like, okay, it looks like this. So again, I can get all the sound information from this this song data set. So here first I'm gonna extract all the sounds information from this data frame, then insert it to the sound table. Okay. So first here we can see sound data equals, right now this is my DF, it's a data frame. So about the song table, I need song ID, title, artist ID, year, and duration. I can get all the information from here, right? So I take the columns of the data frame. Then I use value, because the value gonna give us a list. If you only use, if without value, we have a data frame. And with value, we have a list. So this is the list here, which is good. And now we're gonna insert this information into sum table. Okay, so we use sum table insert and sum data. The sum data is what we get here. So here is the statement we will use. So CUR execute sum table insert sum data connect CONN commit. Let's run it. Okay, so far actually I insert one record into the sum table. So let me check if it's true or not. Okay, where is my sum table? Okay, so here is my sum table. If I run this one, I'm supposed to have only one row return. Okay, good. So we have one row. So you can see we have song ID, title, artist ID, year, and duration. This is what we have. Supposed to be exactly the same thing as here. Okay, so similarly, we can insert a record into the artist table. So I go through the code quickly because it's exactly the same. So now I go to test the artist table. So here's my artist table. Okay, good. I have one row returned. Okay. So now we could process the log data. Yeah, it's the same thing. And we take one file, one log file, and we use Python read JSON so we can check the file, can check all the columns. And because we have this TS is time, so we could extract the data from here, then transform the data, finally store the data in our timetable. So here, those, the page equals to next song, mean this song is played by the users. Okay, so here we make a copy so that if we make some change, this original data frame won't change, because later we're gonna extract other more data from this data table. So yeah, I think those here you have all the code you need on in the workplace, I guess. So I just walk through here. And then you will get all your information, and then here. So here, because here is a little bit tricky, and in the sound data case, each data frame has only one record, one row, one information. But here, each data frame have like a lot of information, a lot of rows. So we need a for loop here. I guess probably some of you don't know what's this for loop. What this for loop does, because this df enter rows, you never see it before. The first thing is, of course, you can Google it. You can see the doc, and this function is well explained. But actually, you can also print this I in row and to see what it looks like. But it's better to do a break here. You don't want to print everything. Yeah, so we'll see. Okay, yeah, we can see. Okay, here this I is, yeah. So probably it's better to do this, so I can see which one is which one. See, another good idea. Okay, I'm gonna do this. Okay. forgot. Remember, it's supposed to be this one. Okay, so this I actually it's indexed here, and the row it's all the rows we got from here. And if you're not happy about it, you can print tab row. Okay, it's a panda series. Good. So somehow we understand what's this time div dot it rows could return us. Basically, it's this I is the index and the row it's a Python series which contain all the columns. Okay, now I don't need it anymore. Okay. So now we can insert each row into our timetable. So this the for loop. Okay. So now we go back to the test Python to see what happened. What will happen? Yeah, because as we can see now, actually this timetable actually contain more than one like record, right? So we can see several things here. Where is my timetable? Okay, this is my timetable. I could check. Yes, because I have a limited 5, so I have like 5 rows. Right? Oh, that means it work. Okay. Then we could do the user table. It's the same thing. Just we need different columns. Okay. Then I insert all the information into the user table. Where is my user table? Because I want to test it. User table. Yes, here. So how many rows do you think I could have? 5, right? Yes, I have 5 rows here. Okay. So finally, is the sum play table. I think the sum play table it's the most complicated one because we need to use 2 tables. Yeah, we have the explanation here because here we don't have artist ID, but we need artist ID. Right? We need artist ID and song ID. Let's go back to sum play table to check. I'm glad I have sum play table. Stayed here. So I have sampling ID. I don't know. I don't have sampling ID, but it's okay. We can generate some sampling ID when we create our table. Okay, then we need user ID. Yes, but we also need song ID and artist ID. This user ID, we can find it in the log dataset, and song ID and artist ID we can find it in the song dataset, I guess, right? Let's see. Yes, artist ID and song ID, right? But somehow we have to combine those 2 data together. Okay. So let's see here. So here it's like, okay. So we go through this data frame row by row, and we need its song, artist, and then the length of the song, which we can go from this table, from this data frame, sorry. Okay. And if song ID, artist ID equals to the result, okay, then sorry. Yeah, so here we have if else. So if the result is not empty, the song ID and RTS gonna equal to the result. And here actually it's a statement which we can get song ID and artist ID. All right, here is song select. I forgot to explain this song select. Basically, the song select. This song select statement is also in here SQL query. Yeah. So song select. We can select the song ID, artist ID from the song table and join the artist table. So we can have song ID and artist ID, right? Okay. So here is the way select song ID and artist ID where this song gonna have, yeah, we have the same song name and artist name and the length. So yeah, so if this one is the same, we're gonna have our song ID and artist ID. Okay, then we could insert all the information into the song play table. Yeah, this one's a little bit tricky. Yeah, but you need to spend more time on it, I guess. Okay, so let's commit it. Okay, so right now I insert information into song play table. I could see something from the song play table. Now, this is my song place table. Okay, so I have something here. I have song play ID, start time, user ID level, song ID, artist ID. Oh, have a lot of none here, but don't worry, it's okay, it's good. And song ID, location, user agent. Okay, good. So this means our ETL pipeline works well. So right now we need to complete this ETL Python script. Okay, I don't want to explain too much of this table. Basically, you can follow this Python script in the workplace. Yeah, if you follow it, I'm sure you could finish it. But if you have any question about it, you can message me. I would be really happy to help you. Okay, so now let's run this one. Let's run this ETL. Run ETL Python script here. This one because I ran it before, but we need to run again. Good. Processed. Okay. But you can always run it in the terminal. I prefer to do it here. Too lazy to go back to my terminal. Oh, okay, good. It's done. So right now we have done all the works, but I would like to check, like if I have the good thing here. So here's some play table and the user table. I mean, in this case, the song table should have more records. Yes. And also the artist table supposed to have more records because I already processed every files in the data set. So, okay, good, we have 10. Good, we have 5. Okay, I think that's all. I think we finished 5 of the file. And the last part, I guess, should be sorry, here I have a little bit explanation about the percent sign and SQL. If you are interested, you can check it online by yourself. Okay. So now it's a little bit about README. So how to write README. So basically README, you need to say, okay, what I have done, and explain why I have done this, and from the perspective of the company. And also we need to justify the schema design and ELT pipeline design. So we need to say, okay, why our schema is good, why I use it's like a fact table and dimensional table, things like that. And finally, we need to state ETL pipeline. Okay, ETL pipeline. Okay. Here, so you can see something like this in this database. There are 5 tables created by this ETL process. And for the sum table, I did word. And for the artist table, and for the user table, timetable, something table, it's like how you extract the data, how you transform the data, and how you store the data. So basically, that's README. Okay, good. So this is the project 1, and today I said I'm gonna say something about project 2. So I'm gonna do it really quick because we don't have too much time left. And for this one, I would like to do it like in project workplace. Oh, too bad. So let's go to the introduction. So this one is, okay, right now we're working on project 2. Okay, project 2. So the project I did modeling with Cassandra. As we can see, we still work for Sparkify. And right now the data is not in JSON format. Instead, it's CSV files. And it's the same, we need to do data modeling with Apache Cassandra and to complete ETL pipeline using Python. Okay, here's the project details, and all the data is CSV file. And this is what we need to do. We need to create K-space, set K-space, and we need to create our table, insert table, and job table. And finally, we need to test by running the proper select statements with correct where clause. Okay, let's get started. What's happening? Someone's using my workplace. Okay, don't know what happened. What's happening here? Oh, good. Okay, very good. So here's a project template. Basically, we need only follow the instruction in this file. Okay, so here's part 1. Yeah, but we need to know we need to do non-SQL modeling by using Cassandra, Apache Cassandra. So first we have to import all the Python file. Okay. So the second is we create list of file paths to process original event CSV data file. Okay, so here It's the same as what we did, define function to get a list of our files. In this case, a CSV file. Okay, some of you see I do a break here. Why I do break here? Because I see if I don't do break, the print length gonna be like 8. Why actually? Okay, I don't have. Oh yeah, I think I'm okay. I can explain why to you, because they have an IPython checkpoint file here, which is kind of annoying. You see, so first I have. Let's do it here inside my for loop. Okay, so first I have like 30 files in here. Okay, that's all the file I want. And then I have another 8 files, which is checkpoint, okay, which I don't like it. And I don't, yeah, you can remove it actually, but I'm too lazy, so I just use a break. Yeah, the break gonna stop the for loop, right? So I won't have this part. Okay, so let's check. Okay, yeah, because I break, so this print thing won't work. So if I put here, you can see, okay, it worked, right? I have 30 files. Okay, so I don't want to. So I have my file path, which means I have like 30 files in my dataset. Okay, here is a funny thing. Oh, it's not funny thing, it's a very interesting thing actually. So because I have 30 CSV file, and what this code, gonna combine all the file, combine all the CSV file into one. So I don't want to explain the code like row by row here. But anyway, you're gonna have like 8,000 rows, but some of them, yeah, yeah, here are the rows. And right now you like rewrite the file. You like drop this part. If the row equals none, you're gonna drop it. The continue mean we do nothing. We continue our for loop. So in the end, the new file gonna have those many records. And here it's another solution, because I'm good at pandas, so I'm not good at pandas. I mean, I like prefer pandas. So I use pandas, this method. If you would like, you can Google it. Pad. Yeah, I use this method. I can concatenate all the CS file into one. So I can check the shape. That's the same. And then I drop the none. Okay, I got exactly the same. Oh, here one less, because here this one counts the header. I mean the name of the column. And so, but here I don't. Anyway, it's the same. Okay, so right now all the file stored in one CSV file, which is called event data file new CSV. Okay, so here is the modeling. And first, can we, it's the same thing, we connect to Cassandra, and then we have a session. Okay, then we create case base. Okay, yeah, we see this statement in our exercise before, and then we set case base, right? And yeah, we know NoSQL data modeling is one table for one query, right? So here we have 3 queries. That means we need to create 3 tables. So here I only like work with you for the first query. So the first query is give me the artist, song title, song length in the music app history. That was here during session ID 338, item in session equals 4. So here's the like statement. We're gonna select artist, song title length from event app where session ID goes to 3, and yeah, something item in session equals to 4. Okay. I don't think it's from event app, right? I think it should be app history or something. I mean the table name. Okay, so here's the query. The query is create table if not exist. Session history. Oh yeah, I called session history. And then inside I include session ID, item session, artist name, song title, length, primary key. Primary key is session ID and item in session. And actually, don't like it because it's kind of too long. I could do something like this. 1, 2, 3. Oh. 1, 2, 3. Then do the multiple line because this is better. Kind of like easy to read, right? Yes. Okay. So yeah, I print the query to check if it's correct. I believe myself it's correct. So I execute my query, and then I take every record from the CS file we created before, and then we insert the information into the table. Not the table, sorry. Yeah, the table. Yeah, we just create, which is called session history. Okay. It's gonna take like a minute or something. Okay. Oh, good, no errors. So finally, I'm gonna do the select statement to verify if my like modeling is good. Okay, good. I have all the information I want here. Okay, good. Then you can do the data modeling for the second query and data modeling for the third query. And in the end, you should drop the table. You just create, I will just drop only this one because I didn't create a table. So it's gonna give me an error. And then finally, I'm gonna shut down all the sessions and clusters. Okay, so this is for the project 2. And no, probably it's not very clear so far. So if you have any question, you can just message me. I would like to help you. Okay. So the final part is I would like to share some questions which I found very interesting. The first one is what is the difference between primary key, partition key, composite key, and clustering key in Cassandra? Okay, and the answer is here. Okay, so the second one is what is as we see before in the relational data modeling. Instead of using like the normalized data modeling and denormalized data modeling, we use dimensional modeling, right? So we want to know why. So here the third question is why we use dimensional modeling over denormalized relational data model. I think this one's very interesting. You can click the link to see the answer. And another one, and this one actually kind of like a paper or blog. And what is the role of normal forms in dimensional modeling? Yeah, actually, yeah, probably you could think about the fact table and dimensional table. So is the fact table is normalized? Is the dimensional table normalized? And if you are interested in these questions, you can find the answer here. Okay, I think that's all for today. And thank you. And in the end, do not forget, you could message me if you have any questions. Okay, bye-bye. Oh, hi. Stop live.